Okay, welcome to 6.2, starting with systems of equations. So first, let's just look at one equation really quick. One equation looks like maybe, let's take a real simple one, y equals x, okay? Now, y equals x has an infinite number of solutions. Think of it like a relationship between x and y, or a constraint on x and y. In other words, if you know one, you can find out the other. So we could list all the, well, not all, we could list some of the solutions to this, right? We could have if x equals 1, then y equals 1. Okay, so we get a bunch of ordered pairs that look like this: 1 comma 1, 2 comma 2, negative 13 comma negative 13. Any numbers you can think of, 0.46 and 0.46. And so then if you go ahead and graph these, what they end up looking like, and I'm going to pull up another program to do this. And if you graph this, what you get is, you get y equals x, and it's this nice diagonal line where you have 1, 1 here, 2, 2, 3, 3, 2.5, 2.5, 2.25, 2.25. So it's every possibility of y equals every possibility of x, and when you graph it together, you get a line. Okay, so now let's look at a system of equations. A system describes something that has more than one part. So if we put two equations together, again, let's start with two really easy ones. Let's start with y equals x and y equals negative x, okay? And this little bracket here, open on one side, means these go together, okay? This is part of a system. So what it's really saying is each one of these two, y equals x, has an infinite number of solutions, and y equals negative x has an infinite number of solutions. So each one of these looks like a line. Okay, and everything we're going to be dealing with is a straight line or a linear equation. Okay, when we put these together, we get three possibilities for solutions. Okay, going back to our graphing program, the three possible solutions are either your two lines intersect in exactly one point. I already have y equals x drawn, so let's graph y equals negative x, okay? And you can tell that these two lines intersect at exactly one point. And this is by far the most common, and most every problem on your homework will be this case, where two lines intersect at one point. So the only place that both y equals x, like 1 equals 1, 2 equals 2, 3 equals 3, and y equals negative x, so the only answer to both equations is 0 equals 0. Okay, so that's the way to solve it. Now there's two other cases though. Now you could have two lines that don't intersect at all. So let's get rid of this line, and let's put a parallel line, y equals x plus 1. So it's also the same slope, but now it has a y-intercept of 1. So now these two lines don't intersect at all. And so if you were to try and look at the solution to the system of equations, I'm going to go back here to Microsoft Word just to look at it. If you were to try and solve y equals x and y equals, x plus 1, there is no solution to that because those two lines never intersect. In other words, if you look at all the pairs for y equals x, like these, and then you look at all the pairs for y equals x plus 1, like 1, 2, and 2, 3, and negative 13, negative 12, and so on. These two can never possibly have the same answer, because whatever you plug in for x in the first one, like say 1, you'll get 1 out as y. And when you plug 1 into the second one, you'll get 1 plus 1, or it's just a totally different answer, 2. Okay, so these two lines are parallel and never intersect. The third and final case is, okay, well let's say these are parallel, but now let's say these are actually the exact same line. So now they intersect in every possible point. So every possible point is a solution. So let's go back to Microsoft Word. Now if I said what's the solution to y equals x and y equals x? Well, all of these things we talked about here. These are all answers, plus 3, 3, negative 5, 5, 0, 0, 100, 100. So there's an infinite number of solutions, okay? So that was some big picture, and I hope I didn't scare you with that. Now let's do a couple of problems. This is just going to be normal graphing like you've done, so there's no surprises. What you're going to be doing now is graphing two lines and seeing where you intersect. Okay, and just to remind you, there are three cases. Okay, case one, let me just scroll down a little bit here and bring this to the top. Okay, case one is two lines intersect in one point. So there is one solution. Okay, case two, two lines are parallel and never intersect. There is no possible solution to this system of equations. And finally, there's case three, which means the two lines are parallel and are actually the exact same line. And in this case, all real numbers are solutions, or a way I like to think of it is everything is a solution. Okay? Infinite number of solutions. Whoops, infinite number of solutions. All right? So, let's do a problem. Okay, I've pulled up your future classwork. Okay, and let's just look at problem number 2 here. Okay, problem number 2 gives us a simple system of equations and asks us to graph these two lines. Okay, so let's write these down. X plus y. Okay, just to do this problem, x plus, oops, I hate to capitalize this, okay. X plus y equals 6, and down on the next line, we've got 2x plus y equals 8, okay. So let's separate these a little, and we're just gonna graph these. So first thing we do is we're gonna minus x from both sides, and we're gonna get y equals negative x plus 6. And again, all we did was subtract this x from both sides, and so we get this. Okay, we're going to graph that. And then down here, we're going to subtract 2x from both sides and get y equals negative 2x plus 8. So in other words, for this one, we've got a slope of negative 1, which of course is negative 1 over 1, and a y-intercept of 6. And then for this bottom one, we've got a slope of negative 2 and a y-intercept of 8. Okay, so let's go over to our other program and graph it. Okay, so we got y equals negative x plus 6, and y, well, let's erase that original one. Okay. So y equals negative x plus 6, which we have in there, and y equals negative 2x plus 8. Okay, and so we can see they intersect at one point here, which is over 2, 4, so the point is 2, comma 4. In other words, the solution to this, the only possible answer that works out of every infinite solution is 2, comma 4. So let's go back to our equation and test it. Okay, so let's look at our system of equations. Let's get rid of all this work. Okay, here are our two equations, and let's see if the point, okay, 2, comma 4 works in both equations. Let's plug it into the first one. Okay, 2 for x plus 4 for y equals 6. Well, sure enough, 6 equals 6. That one works. Great. Okay, let's plug it into this bottom one. Okay, so 2 times 2 for x plus 4 for y equals 8. And so it's going to be, whoa, on to the next page we are. Okay, let's raise this up a little. Okay, and so we get 4 plus 4 equals 8, or 8 equals 8. Perfect. So it works in both equations. So this 2, comma 4 is the one and only point that is the answer to both of our equations. Let's make it really big and important. Okay, so that is the solution to the system of equations x plus y equals 6 and 2x plus y equals 8. These two lines cross at exactly one point, and we found that by graphing. That is the point, that is the answer. Okay, let's do just a couple more examples and you can get started on your classwork. All right, here's a nice problem, because what they do is they actually graph all the equations for you and then ask if you understand what the solution to these are. Okay, so let's take this one first. This, oh, I can't highlight it. Okay, so x minus 2y equals 4 and x plus 4y equals 4. So let's find these two lines on our graph and see where they intersect. Okay, so let's look over here. X minus 2y equals 4 is this line. Okay, and x plus 4y equals 4 is this line. So these two lines cross at this point. So the solution to this system of equations is the point 4 comma 0. All right, now B, we have the line x plus y equals 7, which you would graph, but they were kind enough to graph it up here. Okay, so we take our other one, y minus 3x equals 3. So we look, and there's y minus 3x equals 3. So here's our first line. Here's our second line. They cross exactly one point, which is 1 comma 6. And that is the solution to that system of equations. And you can go on and do a few more. Okay. The only other trick they throw at you is they use a's and b's instead of x and y. And this is only one problem. And you can do this just like an just like an x and a y. It says draw the a-axis and draw the b-axis up. So the a-axis is just your x-axis, and the b-axis is your y-axis. So let's do this last problem together. Okay, so let me just see. A plus 2b is 11, and 2a plus b is 13. Okay, so we've got a plus 2b equals 11, and 2a plus b equals 13. Okay, and let's get rid of all this other stuff. All right, so we just need to graph these. Let's change this right away to x, and let's change this right away to y, and solve the rest of the problem as if these were x and y. Okay, so let's subtract the x from the other side, and we get 2y equals minus x plus 11, which gives us, dividing it all by 2, y equals negative 1/2 x, okay, plus 11 over 2, okay, and down here you get, minusing the 2x, y equals negative 2x plus 13. All right, so let's go to our graph and graph these two. Okay, so we get this. Oh, let's get rid of our first two. Okay, and we get sorry about that. I graphed the first one wrong. There we go. All right, and so these two lines, if drawn correctly, intersect at one point and only one point, which is 5, 3. And so the solution to this, going back, is 5, 3, and we can check by plugging it into these original questions. And so it is 5 plus 2 times 3 equals 11, which is 5 plus 6 equals 11, which is 11 equals 11. Yes. Let's check it in the second one, and we get 2 times 5 plus 3 equals 13, which is 10 plus 3 equals 13, or 13 equals 13. Again, this works in both, and the solution to our systems of equation is this one and only point that works in both equations, the only place these two intersect. The end. Enjoy the chapter.